everyone, welcome back to another video of Daily LeetCode Challenge Streak Series, and in today's video we have a new question that says set mismatch. Let's read the question. You have a set of integers s which originally contains all the numbers from 1 to n. Unfortunately, due to some error, one of the numbers in s got duplicated to another number in the set, which results in repetition of one number and loss of other number. You're given an integer array nums representing the data status of the set after the error. Find the number that occurs twice and the number that is missing and return them in the form of an array. Now let's understand this question with the help of an example. Now if you carefully look at this example 1, 2, 2 and 4, we have the number 1 and we have the number 4. But if you look at 2 and 2, this number 2 is duplicated. So instead of 2, what should we have here? Since they are consecutive numbers, that is from 1 to n, you should have the number, the consecutive, as in the number that is consecutive to the previous element. So in place of 2, it should be 3. In place of 2, it should be 3. So 3 is the missing number and 2 is the duplicate number. Now even in this example, 1, 1, you have two elements here. So the array should have 1, 2. But what do you have? You have 1 again. So 1 is the duplicate number and 2 is the missing number. Okay. Now, how can we solve this question? First approach is by applying the vector approach. What will we do in this? We will simply initialize a vector with n plus 1 elements, okay? With n plus 1 elements. Why n plus 1 elements? Because this number starts from 0 and usually you have to so to have the index starting from 1 and to have all the elements, we will have n plus 1 elements in the array. So we don't have to use this 0. Okay, now what will we do? So for each number in this array, we will be incrementing the count in their respective indices, and in the end we will iterate to this vector again and we will see in which index the value is 0 and in which index the value is 2, and we will return them. So if you look at 1, 2, 2 and 4, you will initialize with 0, 1, 2, 3 and 4. Now you will go to 1 first. And you will increment it, you will initialize everything to 0 first, and from 0 you will change it to 1. Now then you will go to 2. What was here earlier? It was 0. Now you will change this to 1. Again you are at 2. So you will change this to 2 now. Next you will go to 4 again. So this will become 1. So if you carefully observe, the frequencies are 1, 2, 0 and 4. 0 and 1. So whatever is 2 here, you will return that as the duplicate element and the one with 0 is the missing element. Now what is the time complexity of this thing? Since we are iterating over all the elements here to update in the array and iterating over again this frequency array to check for the duplicate and missing, time complexity would be O of n plus O of n, which is nothing but O of n. Now, what is the space complexity? Since we are using an additional array of n plus 1 elements, we will have the time complexity to be O of n again. Now, what is another approach that we can think of? It is nothing but the math approach. Now, if you carefully look at this 1, 2, 2, 4, in the question it is said that you will have elements ranging from 1 to n. You have elements ranging from 1 to n. If you know the formula that you've studied in your schooling, that the sum of n elements, the formula for this is n into n plus 1 by 2. Correct? So if the original array is 1, 2, 3 and 4, what will be the original sum? It will be 4 into 4 plus 1 by 2, that equals to 4 into 5 by 2. 2 ones are, and this is 10, correct? But now this is the array that is given. So what will be the sum 1 which is duplicate? Okay, the one with duplicate, it will be what is it? 4 plus 2 6, 6 plus 2 8, 8 plus 1 9, 8 plus 1 9, correct? Now what we'll do is we will take a set, we will create a set and transfer these elements. So this will be unique set, and we'll transfer the elements of this array into this set to see the sum of the elements without the duplicate. So it will be 1, 2 and 4. Now what is its sum? 6 and 7. 6 and 7. Now Now, if you carefully observe, the difference between the duplicate array and the unique array, it will be 9 minus 7. So, if a duplicate element is added, if a duplicate element is added, it is resulting in the sum 9. If the duplicate element is removed, the sum is 7. So, what will the duplicate element's value be here? It is the difference between this duplicate array sum and this unique set's sum. Correct? So 9 minus 7, so the element would be 2. Okay? How do we find the missing element? For the missing element, since we have only once occurring elements in unique array, and we have the original sum to be 10, and with all the unique elements we have it to be 7. Now what will be the missing element's difference be? It will be 3. So the missing element is 3. The duplicate element is 2 and the missing element is 3. Now, what is the time complexity? For time complexity, since we are iterating over all the elements to get the sum, the time complexity would be O of n. And for space complexity, since we are using an additional set to check for the unique elements, the space complexity would be O of n as well. Okay? Now, how do we optimize the space complexity from O of n to O of 1? Now, the third approach that we are going to use. Now, if you've also studied math properly, you will know that XOR is a math approach that will cancel off the same elements. Cancel off the same bit elements. Like if there's 0, 0, you'll get 0. If it's 1, 1, you'll get 0. But if it's 0, 1, you'll get 1. And if it's 1, 0, you get 1. Okay, this is XOR. Now, what we can do is that if we have something like 1, 2, 2, 4 given, we can XOR the given array with an array of elements from 1 to n, which would be 1, 2, 3 and 4. Now, when we XOR it like this, what will happen? 1, 1 will cancel off. 2, 2 will cancel off. 4, 4 will cancel off. What are we left with? We are left with 2 and we are left with 3. We are left with 2 and we are left with 3. Now, here's the catch. Now, you know that let's assume x to be our repeating number and y to be our missing number. Okay. Now, what we can do is that we know for sure that for every elements that have not been cancelled off, for two different elements, there will at least be one differentiating bit that will make it different. For example, if I have 2 here, how do I write it in bit? It will be 0, 1, 0, correct? Now, how do I write 3? For 3, it will be 1, 1 and 0. Now, if I XOR these two, 0 and 0 will go, so it is 0. 1 and 1 will go, it is 0. But I have 0 here, I have 1 here. So, since these are two different elements, I will get 1 here. So, for every two different elements, their bits will be different and there will at least be one or more than one differentiating bits that will result in a different answer. So, for every given number, if we differentiate into two groups, one with 0 at the differentiating bit and 1. It's like, see, if you carefully observe 2 here, you have 0 to be the differentiating bit. For 3, it is 1. So, it's either 0 or 1. So, you put 2 into this part and you put 1 into 3 part. Okay. Now, I'll tell you the intuition behind this thing. Now, what will we do for 1? Now, how do you write 1 in bits form? So, it's 0, 0 and 1. So, now since the second bit here is differentiating, for every element in here, just look at the second bit, okay? For now, since the second bit is differentiating here, we will look at the second bit and categorize them accordingly. Now, since in 1, we have 0, let's put 1 in the 0th part. Now, let's take a different number, 2. Since 2 is a part of 0 club, we put that in 0. Next, even 2 again. Again, we have a number 2. So, I put that 0 part again. Now, 4. So, what is 4? It is nothing but 1, 0 and 0. Now, this 4 is a part of which club? It is a part of the ones club, since the second bit here is 1. Now, let's also do that since we did it with ARR of I elements. Now, let's do it with 1 to n elements. 1 to n elements. So what will we have? 1, 2, 3 and 4. Now what is 1? What is 1 second bit? It is 0. So it will go into this again. Now 2. Where is 2 again? 2 is here. So 2 will go into this again. Where is 3? 3 is here again. Now where is 4? 4 is again here again. Now what will we do is that we will do the XOR of elements within itself. Okay, we will do the XOR of elements within itself. Now why are we doing this? If we do it, whenever XOR is there, if there are even number of same numbers, it will get cancelled off. But if there are odd number of same numbers, they won't get cancelled off. Now if you carefully observe here, this 3 and 3 will get cancelled, 4 and 4 will get cancelled, and we won't have anything here. Now if you see the same here, 2 and 2 will get cancelled, 1 and 1 will get cancelled. But what are we left with? What are we left with? We are left with 2. Correct? We are left with 2. But also, here, if you carefully observe, we didn't have 3 in the previous element. Here, we didn't have 3. Correct? In 1, 2, 2, 4, we didn't have 3. Only in 1, 2, 3, 4, we have 3. So, 3 will only repeat once here. So, 3 will only repeat once here. So, it won't be striked off with anything. It won't be striked off with anything. Only 4 and 4 will be cut, 2, 2 will be cut, 1, 1 will be cut. And in the end, the duplicate element will be remaining and the missing element, because it couldn't be XORed with anything. Correct? In the end, we will just traverse through the array. In the end, we will just traverse through the array again and check which element is appearing twice and which element is appearing only once. And with that, we will be returning our duplicate element and missing element. We are doing nothing here. We are just doing the XOR, which is we are just cancelling. We are cancelling every element occurrence with its own occurrence by considering the elements from 1 to n by 1 to n, and in the end we are just checking. We are taking the differentiating bit and we are categorizing them into with respect to the differentiating bit and doing the XOR within the same group. Within the same group, we are doing the XOR, and in the end we are returning the duplicate and missing element by counting the number of occurrences. So, the time complexity, what will the time complexity be? Since we are iterating over all the elements while doing XOR, time complexity would be O of n. Space complexity, are we storing anything anywhere? No, we are not storing, we are not using extra space. So, the space complexity here would be O of 1.
Okay, now let's quickly code this up. We have a function find error nums given, in which we are being given an input array nums. Now, what are we doing first? Let's get the length of this array nums. Okay, next, what are we doing? To get the XOR elements of this array and to get the XOR of 1 to n elements, let's create two variables to store the result in those. So let's name it XOR all for the XORing of all the elements from 1 to 10. Let's initialize it to 0, and another variable named XOR ARR, in which we are XORing the elements within itself, and let's initialize it to 0 as well. Now let's calculate the XOR of elements from 1 to 10, which is nothing but XOR all. Okay, now for I in range 1 to n plus 1. Why 1 to n plus 1? Because we are directly taking 1 to n elements, so it is that. Now how do we XOR it? We just use this thing and we use this symbol is equals to, and we are XORing it with its own element. Now let's XOR this given input array as well. So for num in nums, as in this array, we are XORing it to itself. So it is, so we have the length already. So XOR ARR and this equals to num. Okay, we are XORing it to itself. Now what are we doing in the end? We are getting the differentiating bit. Between this and this. Correct? We are XORing this one and this one in the end. Correct? We had 1, 2, 2, 4 and we have 1, 2, 3, 4. So first we are XORing this whole thing, then XORing this whole thing, and we are going to XOR the results of both of these. We are XORing the results to each other. Okay? So let's have a variable XOR result, which is equals to XOR A RR and XOR of everything. Okay, now what are we doing next? Now when we had 2 and 3, when we had 2 and 3, we were trying to get the differentiating bit. So whatever is the different bit in there, we are trying to get that, and we are trying to group them into two parts, 0 and 1, such that in the end we will again XOR elements in each of those respective categories. If you are not trying to understand what I'm saying, just go back to the explanation part. Watch it again and come back here. So we are making two groups again. After making two groups, we are XORing them among the elements itself, among the same groups itself, and then we are returning the missing and duplicate element. Now, how do we find it? How do we find the right bit element? So for that, what we'll do is that we will take this XOR result. If you know the basics of choose, complement and add properly, we know that when you do the complement, so 0 of 0 will be 0, 0 1 will be 0, 1 0 will be 0, but 1 1 will be 1. So wherever we have 1, so we are going to do the AND operation with every bit. And wherever we get the answer to be 1, we will store that value. So what we are doing, we are finding the right, we are getting the rightmost bit here. So rightmost bit is equals to XOR of result, and we are applying the AND operation, and with the 2's complement of XOR res only, we will be able to get the differentiating element. Okay, XOR of res. Now what are we doing next? Let's set two variables, XOR set equals to 0 and XOR not set equals to 0. Now why are we doing this? To categorize into two parts and to XOR the elements among themselves. Now we are not creating any two sets to put them into each of those. We will just initialize two different variables first, and according to in whichever groups they are, if it is a part of the 0th set, then it will be a part of XOR set. If it's the part of 1 set, it means that there is a differentiating bit, so it will be a part of the XOR not set. So in the end, when we are XORing all the elements within the groups, we are not going to do that within the group itself. We are not going to do like that. We will directly keep updating the XOR set within the element we find. Whenever we find a new element which is a part of these respective groups, we will XOR the element with the current XOR value, and we will update it, and in the end we will return the duplicate and missing values. So for I in range 1 comma n plus 1, what we are doing now, we are making the groups. So if I, and we are now applying the AND operation. Okay, if I and rightmost bit, okay, is not equal to 0, meaning it is equal to 1. If it is equal to 1, then what does it mean? It is a part of this group, so we will XOR it by XOR set. Okay, we will XOR it by this set. Okay, XOR is equals to I. Now what's the otherwise case? It means that the rightmost bit is 0, and the result that we are getting, the differentiating bit is 0, so it will be a part of the 0th group, so we will XOR it with this variable. Okay, now let me just change it into small case. So yeah, XOR not set, okay, and equals to I. Now next, what are we doing in the end? Now we did that for 1 to n elements. Now we have to do that for the nums array as well. So for num in nums, what we are doing, if same formula again, if we are checking if it is 0 or 1 for these elements. Earlier we did from 1 to n elements. Now for any XOR operation you do, you should do for 1 to n elements and the given input elements. Okay, so rightmost bit is not equal to 0, then XOR set of I, else it is, let's copy paste the same thing since it's the same, it is this. Okay, now After this, what are we doing? We are checking if this element is there in nums or not. If that is there, it means that it is a duplicate element. If it is not there, then it is the missing element. So for num in nums, we are checking if num equals to this XOR set value. Okay, if it's equal to XOR of set, then we will return XOR set comma XOR not set. Okay, it means that if this is there, it means that the XOR set, in the end we are going to get two values, XOR set and XOR not set. Now we have to find out which is the duplicate value and which is the minimum value. So we will iterate over the nums array. If we find the XOR set value in this, it means that it is the duplicate array and XOR not set is the missing value. If we don't find XOR set in this thing, it means that it is the missing value and this is the duplicate value. So in that case, we will return XOR not set and XOR set. Okay, let's check if the code is right. We have all, okay, sorry, this is not I here, it is num, because for num in nums, if it is I, let's run the code now. It's accepted, and let's quickly submit the code. And this works. So we have the streak 11 now. Thank you guys.